flying is resting, is kept vertically, on the ground, such that a base edge parallel to VP, a base edge parallel to VP, right? Base edge, right? So it is cut by a plane. Which is perpendicular to VP, cutting plane perpendicular to VP. Come on, 35 degree incline to HP, 35 degree incline to HP, and bisecting the axis, Draw the lateral development of the retained bottom portion of the pyramid, Right. So we are seeing development. Straight away you draw the projection. Make it fast. Draw the projection of this center, the pyramid, the pentagonal pyramid of 25 and height 65. Yes, side is parallel to VP. Okay. Draw the top view. Draw the front view. So represent the cutting plane. Mark the cutting points. Make it fast. Drawn for the given problem, right? The side is parallel to VP. Okay, it is resting on the ground with its way, such that a base side is parallel to VP. I have drawn the top view like this, right? I have represent the rotation and I have marked the center, right? Then you see front view I have projected as usual, right? I have projected it. Then I have represented the cutting plane such that it is bisecting the axis and the cutting plane is 35 degree inclined. So it is 35 degree inclined. Cutting plane is 35 degree inclined. And I have represented the cutting plane in the front view. That is, since it is perpendicular to VP, I have represented it on the vertical plane. That is on the front view, right? So then, since it cuts, the cutting plane cuts all these slant edges. So I have 5 slant edges. It cuts all these slant edges. So I will get 5 cutting points. So I have marked the cutting points in order, right? First of all, lower end to the visible cutting points I have marked. Then I have given the hidden cutting points, right? Once this is over, you are asked to draw the lateral development of the retained bottom portion. That one I have darkened there, right? So you are going to draw the lateral development of the retained bottom portion of this pyramid, right? First of all, you see a pyramid, the development of a pyramid, okay, any pyramid, first of all, we need a true slant length, right? Something similar to your cone problem, we need a true generator length, right? In cone, we need a true generator length. It is something like a cone, but it's a pyramid. So we need a true slant length. So which of these slant edge will give me the true slant length in this orientation? which of these slant edge will give me the true? None of the slant edge in this orientation AO, that is not parallel to VP. Okay, that slant edge in this orientation is not parallel. Listen all of you, listen all of you. So I need a true slant edge to have my development. You see here, development, you know, this is going to be the development of a pyramid. Right? Say I have 6 sides, this is the development of a pentagonal pyramid. Right? So for this, what I need what is this length? This length is nothing but my slant length. That is exact slant length, true slant length. So do you have a true slant length in this orientation? Okay. So only you have a true slant length in your front view if that slant edge is parallel to VP in your top view. Right, already you know this one. Okay. If a line is parallel to VP, I will have a true length in the front view. If a line is parallel to VP, so similar, this line, slant edge is nothing but a line. So none of this slant edge is parallel to VP. So corresponding front view of that slant edge will not give me the true length. So in this orientation, none of this slant edge is giving me the true length in my front view. So suppose I have orientation like this, the same pentagon. So do you have any slant edge will give me a true length? So this is A, B, C. Which one will give me the true length? OC. So in this orientation, for me, OC in the front view will give me the true length, true slant length. Right? But in this orientation, as per this problem, none of the slant edge is parallel to VP. So what I have to do? So in my front view, none of the slant edge will give me the true length. So what I have to do? I have to rotate one of my slant edge, make it parallel, and I have to project it, and from there I have to measure the true length. What I am going to do? So this OA is not parallel, so I am going to make it parallel. This OA and just I make it parallel by rotating it. See, now it will be parallel like this. So this is an arbitrary location I am rotating. Right? So now this OA, it's parallel. The same length from OA, I am just rotating, I am making it parallel. Just I am projecting this to a new location in my front view. So I will have a new location in my front view. Right? From here, I have to join the O to this location. So this is the line. This is the line what I have drawn. This is the slant line. It's nothing but my true slant length. Okay, true slant length. So you look for the slant edge which is parallel to VP. So if none of the slant edge is parallel, you make any one of the slant edge to parallel to VP and project it to the front view, connect it with the apex. That length is my true slant length. So this is my true slant length. So I can say this is a measuring line. I can give it as measuring line. Why this is a measuring line? So all your cutting points you have to project it to this measuring line and you have to measure it. Similar to your cone problem, right? In cone, the extreme generators will give you this true generator line. Okay, here, so this is the line, my measuring line. This will give me the true slant length. Now, what I have to do to draw the development of similar kind of development, I have to draw it. Which one I have to measure it? This is O2, say, this is an arbitrary location A1. OA1 I have to measure it. Right? For that measurement length, you just measure OA1. This length you have to measure it. You have to draw an arc for that. Right? So this is going to be my OA1. Using this, I can draw an arc. Right? Then what I have to do? Just the base side, I have to measure it. Okay, I have to cut on this arc. Okay, you see here, this is a pyramid. So the base sides will be straight edges. Okay, the bases are straight edges, base sides. So I have to connect the base side length. I have to cut an arc. Okay, so what is this length? OA1. Okay, as per development of a pyramid, you have to get the true slant length. Right? So if straight away in this orientation I will get the OC, it will give me in my front view true slant length. But in this orientation, none of this slant length will give me the true slant length. I have rotated it. So just you measure OA1, measuring length, true slant length. I mark it, draw on. Wait first, draw on. Just this is my OA. This is my OA. Just this is my measuring length, true slant length. Slant length. Right, OA. Now, after that, you have to measure this side, base side 25. In your compass, you got 5 divisions. Okay, you got 5 segments. Drawing an arc like this. Measure 25 mm in your compass equal to the base side. Okay, you got 5 divisions. I have 5 segments. Connect. Okay, this is going to be my A, B, and again finally it ends with A. Right. So the development this. Is it right? Development of pentagonal pyramid alone, is it right? Still, what you have to do it? Bottom portion, it is not a curvical one. For cone, it will be curved. For pyramid, it is a straight edges. Okay, the corners are connected with the straight edges. See here. The corner should be straight. Should be connected with a straight line. So, the corner of the A will be connected with straight line. That is going to be my development of a pentagonal pyramid. So for development of a pentagonal pyramid, you need a true slant length. Okay, true slant length. In your projection, you have to get it. Once you have got, yes, you can draw an arc. You can mark any location. You can draw an arc. Then you can measure your base side length. You can cut. If it is a pentagon, 5 slides. If it is a square, 4 times you have to cut. If it is a hexagon, 6 times you have to cut it. Right? Then you have to connect it. Finally, you have to connect the base corners as a straight line. Right? For cone, you won't connect it. It will be like a curve. For pyramid, you have to connect it like this. Right? Is it clear? For pyramid, you need a true slant length. Now, I have to mark my cutting points. How I can transfer the cutting points similar to your cone problem? Just these cutting points where I have to transfer it to the measuring line. Okay. So just to project this one to measuring line horizontally. So that is the location of my one. The measuring line. Right. Measure O to 1 distance in your compass. Where I have my cutting point 1. Which slantage I have cutting point OA. Right. Measure O to 1 along the measuring line. Remember, along the measuring line. You have to project it to the measuring line. Right. So you measure O1 distance. That you transfer it to OA slant edge, OE, okay. Measure this distance and transfer it to OE. Right. This is my cutting point 5. Similarly, cutting point 2. This is my cutting point 2. Measure the cutting point 2 distance from here and transfer it. Cutting point 2 is on which slant edge? B, OB, right? Measure that, transfer it to OB. So this is my cutting point 2. Right? Then cutting point 4, project it to the measuring line. Right? That is my 4. Similarly, 3. Measure it. This is my 3. It is on OC. 3. It is on OC. Then 4. Measure 4. 4 is on OD. OD. 4. Right. Now you connect these cutting points with straight line or curve. Straight line. Curve. You have to connect the cutting point as a curve only for cone and cylinder. Right. So just connect these cutting points as a straight line. Right. So which is the portion is the retained portion? Bottom portion or the bottom portion? So bottom portion alone you have to darken it. Just darken the bottom portion. Is it right? Still I have to darken it. Is it right? Still I have to darken it. Which one I have to try? The edges also I have to show it. And only for cone you don't have edge. Okay, only generator. You need not show the generator by darkening. Right? Here I have a distinct edge. That edge should be darkening. So you darken to B. B to C. So this is my final lateral development of the retained trimming. Right. See this? This is frustum, you know. Frustum of a square. Frustum of a square pyramid. Right? So if it is like this, it is a frustum of a square pyramid. And keeping like this, you have any real component. It's something like a hopper. Right? Something like a hopper. I can say it is something like a. It's something like a. See here. It's something like what? A dustbin. Okay, dustbin in the shape of a square. Frustum of a square pyramid. It's something like a frustum of a hopper. Right. So you draw the lateral development of dustbin. Draw the lateral development of a dustbin. Lateral surface development of a dustbin, which is in the shape of a frustum of a square pyramid. 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 Of bottom base side. Of bottom base side. Of bottom base side. Bottom base side 200 mm. Comma top base side. Top base side So what scale I can use it here? For example, the scale. Scale, what scale I can use it? What is 10? 10. How it is? Actual size what you are going to draw. Drawn size. The drawn size what you are going to draw it. Instead of 200 you are going to take as 20. So drawn size is 20. Actual size is 200. So it will give me what is 10? 10. So my scale I am going to use it as what is to 10 scale. That is a reduction scale I am going to use it. Right. So you see, the orientation of the dustbin is not given. Just we have to draw a development. Right. Development of a dustbin. It's a square pyramid. Frustum of a square pyramid. It can be frustum of a pentagonal pyramid, hexagonal pyramid. Right. Very simple. Only if you are able to find out the what? True slant length. True slant length you are able to get it. So easily in which orientation I can get a true slant length? Suppose I keep it like this. Do you have a true slant length? Look at this. Look at this dustbin. Okay. Suppose I keep it like this parallel to you. Can I get directly, can I get the true slant length? 45 degrees. So it's nothing but a slant edges. Okay, slant edges, none of these slant edges will be parallel in this orientation. If I keep it like this, the two slant edges will be parallel. So directly in my orientation I can get my true slant length. Okay, it's up to you. So any orientation you can draw it, otherwise you can draw it in any orientation, you can rotate it, you can get a true slant length. Right. So I will try to draw like this itself. Right. So the dustbin I have. So I draw it slide. Dustbin, bottom base. Parallelly I will keep it. Okay, for me. So this is 20 mm. This is 20. Right. Then this is going to be 40, 50. And this height is 15. This is 25. from here, what I will do it, what I have to do it, to find the true slant length. It is a problem similar to your previous pentagonal pyramid in a tilted orientation, okay? Up and down orientation, what I have to do it to get the true slant length. So from here, apex, I have to get the true slant length. Any one slant edge in your top view, you try to rotate Okay, you know, the base is parallel to it. Full stop. Full stop. A thread is wound around the pyramid. A thread is wound around the pyramid from a bottom base corner. From a bottom base thread. From a bottom base corner around the pyramid through the shortest around the pyramid, not through the shortest, around the pyramid. What? Do you understand this problem? Right. What it is given here? Pyramid I have, right, hexagonal pyramid I have, right, a hexagonal pyramid I have. So from a bottom corner, okay, thread is wound around the pyramid. Okay, thread I am connecting, say a wiring or thread, okay, the same problem. The wiring is given around the surface of the pyramid, right, pyramid surface, and it is coming back to the same location. It is wound around from a corner to that same corner, right, the thread is wound. The same problem will be given, okay, wiring is given, okay, with the shortest hook from a bottom base corner, right. Here a thread is wound around the pyramid from a corner to the same corner, right. So what is asked? So what is the shortest distance required for the thread? Okay, what is the shortest distance? Okay, what is the shortest length of the thread required? So what is the shortest length of the thread required? How we can find it out? So a thread is wound around the pyramid like this from a corner to the same corner, okay, around the surface, right, around the surface. So what will be the shortest, how I can find the shortest distance of the thread required? So only if I open the surface in my development only I can find the shortest distance. You see here, this is the projection I have drawn. So here the corner A, okay, from corner A I am having a thread from the corner around the surface and again it come back to the same corner, okay. So what is the shortest distance of the thread required? Okay, what is the minimum length of the thread required? So how I can find it out? I can draw the development. So from the development I can find the shortest length of the thread. How? So in the development I have the corner A at two locations. So the thread is connected from corner A around the surface to again corner A. Right. So how I can find out the shortest length of a straight line? Okay, by connecting in my development corner A to A with a straight line only will give me the shortest distance of the thread. Okay, by connecting in my development, okay, the development you know, see here, so by connecting A to A with a straight line, like this, okay, this is nothing but the thread, actual thread, the minimum length of thread required wound around the pyramid of this size. Is it clear? You have any clarifications? Right. So you can measure A to A distance. Okay, what is that length? That is nothing but the shortest length of the thread required. Right. So the problem you added, what is, take the problem you added, find the shortest, find the minimum length of the thread required. Find the minimum length of thread. Minimum length of thread. Right. The next one, minimum length of thread straight away you will find out. Second one, the front view and top view. Show the thread or represent the thread in the front view and top view. Represent the thread in the front view and top view. Is it clear? Problem is clear. See here, for this orientation I have drawn the projection. So a side is parallel. Right, I have drawn the projection. So what is the? So straight away, first one is minimum length of projection. You have to show the projection. Show the thread in projection. Right. I have drawn the projection. For this pyramid, I have drawn the development. For development of a pyramid, I need a true slant length. Okay, OA is nothing but my true slant length. Do you have a true slant length here? Directly. Directly I have in this problem a true slant length. You can see OA and OD slant edges. In this orientation itself, it is parallel. I need not rotate similar to the previous two problems, right? So OA and OD in this orientation is parallel to VP. So corresponding front view OA and OD, both either OA or OD will be my true slant length. Will give me the true slant length. Directly will give. I need not rotate. Okay. Is it clear? So this measuring OA or OD, using that I have drawn all. Okay, since it is a hexagon of side 25, I have that 25 segments. Okay, I have drawn the development. Then to the first subdivision, the minimum length of thread connecting from corner A to A. So the minimum length in the development only I will get. Okay, since it is on a planar surface, so the corresponding corner A and A, by connecting with a straight line, that is my shortest minimum length of the thread. Okay, so A to A, you have to measure it and you have to write that value. A to A. Measure this. You have to measure this. So what is the length? Okay, length of the thread. Length of the thread. A to A. This 10. Measure it and you have to write it. Right. Then this thread, I have to represent it in my front view and top view. What I can do it? It is a ulta procedure. Right. So I can mark the cutting points in my development. Right. I can mark the cutting points in my development. So previously, first problem, we had a cutting point here. That cutting point we have transferred to the development. Here, I can mark the cutting points right away here. So say A is my cutting point. Say A is here. So this is my cutting point 1, 2, 3, 4, 5. Wherever it is slanted, I can mark the cutting points in the development. These cutting points, I have to transfer it in my front view. Right. Something like a cutting plane, you have to represent it. By connecting that cutting point, is nothing but the representation of a thread in your front view. Right. So how I can go back to my view from here? What I have to do is, just I have to measure it. Okay, my thread is starting from A. In my projection, it is going to start from A. Right. A to A. Right. A. Then cutting point 1 is on its slant edge B. So this I have to measure it, this distance. This distance where I have to transfer it to the measuring line. So here, that is a true slant length line. So to the measuring line, it's nothing but OA or OD, both are same. So that I have to transfer it to that. Okay, that location is my what? 1. This is my measuring line actually. Measuring line. Right. So I have to transfer this. Actually this one is on which slant edge? Actually this one is on which slant edge? B. So I have transferred to the measuring line. Then I have to project it to the B slant edge. Okay. So B slant edge is there. So I have to project to that. That is my location of what? Actual location of cutting point 1. So this is not 1, this is a projected location. Right. Is it clear? You have any clarification here in this step? Just the reverse procedure. Okay, previously we had Then similarly 3, cutting point 3, I have to measure this length, I have to transfer it to the measuring line. Then that C is on which front edge? D, right? That I have to project it to D, horizontally. I have to project it to D. Then that is my 3. Then 4, I have to measure it 4. Measuring line, transfer it 4. That 4 is on E. OE I have to transfer it. OE. That is my 4. Then 5. I have to measure it 5. That I have to transfer it to the measuring line. This is my 5. Then I have to project that to F. F is here. Now you connect these cutting points in the front view. Okay. From A, the thread is bound from the base corner A. So A to 1. Then 1 to 2. Then 2 to 3. Then 3 to 4. 4 to 5. Then again it is coming here. See here. This cutting point 4 is falls on E and F. So 5 to 6. Is it the right representation in my front view? Which portion of the thread is hidden in my front view? Which portion of the thread is hidden in my front view? 3 to 4, 4 to 5, 5 to 6, 5 to 8. That portion of my thread will be hidden. Right? So that you have to show it as a hidden line. Right? That portion of the thread. Okay, this is the representation of the thread in the front view. Can you show it in the top view? How I can show this cutting points in the top view? That you know. Similar to the section of solid, this cutting point, how I can project it in the top view? Directly you project it. A is here. So 1 and 4. 1 is here. 1 and 4. 4 is 5 is here. You can project it. 1, 5. Project it to the top is similar to that section of solids cutting point how to project to the top. So my thread is from starting from A, it goes to 1, then 2, then 3, then 4, 5, then 8. So thread in the top view will be seen like this. The shortest road in the top view, right? Is it clear? Do you have any clarification? This is an important problem. Okay. Shortest length required. Okay, in a pyramid, if you want to find it out, you have to go for the development, you have to connect the point to point with a straight line. That will give me the shortest length of the thread. The same problem will be given in another manner. Listen, maybe an ant is traveling around the pyramid. So what is the shortest route it will take to reach the same point? An ant will start from the corner. Okay, in the textbook you may find a problem like this. And is starting from a corner, it is traveling around the solid from it, and it is coming back to the same point. So what is the shortest route it will take? What is the shortest length it will travel? Okay, so you have to go for the development. So corner A to A you have to connect it. That is the length, is the shortest length, and that is the shortest route it will travel. That I can represent it in my front view and top. Can you do it? So if you are finish this, finish it.